In 2026, the global governance, risk, and compliance market crossed a valuation of $60 billion. But instead of coalescing, this massive tech ecosystem is rapidly splintering apart into hundreds of distinct, specialized nodes. Usually, as tech sectors mature, vendors merge and consolidate. We see this constantly in adjacent fields like cybersecurity. Yet GRC software is doing the exact opposite, breaking apart into hyper-specific micro-specialties. Two major catalysts are driving this split. First, organizations are grappling with a massive global expansion of overlapping privacy and data protection laws. Second, there has been a sudden explosion of complex regulatory requirements, particularly surrounding AI governance and third-party supply chain risk. No single software suite can specialize deeply enough in all these requirements without becoming overly complex. The industry has evolved into a permanent two-speed ecosystem, splitting to accommodate highly distinct operational needs, technology approaches, and regulatory pressures. To survive this complexity, modern organizations must move away from the idea of a single monolithic software platform. The alternative is a layered IT architecture, one that strictly separates overarching governance from rapid edge execution. Within this new framework, artificial intelligence plays a highly specific role. It acts as an analytical accelerant to process data at scale, while human practitioners maintain ultimate legal accountability. Companies that ignore this architectural split and try to force everything into one box end up trapped in endless, retroactive audit cycles. They simply cannot match the speed of modern business deployments. This comparative matrix defines today's market, starting with enterprise integrated platforms. These massive, interlocking engines on the left function as systems of record, tying deeply into corporate departments to centralize audit data, policies, and risk strategies over long horizons. While enterprise platforms offer advanced configuration across complex units, on the opposite side, we find modern specialized tools. These lightweight nodes ingest data streams continuously via API connections. Instead of broad configuration, these tools prioritize velocity. They are built for rapid operational onboarding and ease of deployment. Their specific utility is in automating real-time evidence collection and monitoring controls for targeted, narrow-risk domains, like cloud security. An organization's internal risk maturity typically dictates which of these extremes they initially adopt. A Fortune 500 company might lean on enterprise platforms, while a mid-market firm relies on agile API nodes. Treating these models as mutually exclusive competitors is a structural error. They function as interdependent components of a single architecture. This illustrates the convergence of these models into a unified, layered IT architecture. The enterprise platforms form the foundational base. This foundational layer functions strictly as the systems of record. It consolidates control frameworks, documents risk appetite, and stores historical audit evidence. Directly above it sits the top layer, the systems of execution. These execution systems operate at the edge of the network. They plug directly into daily business applications, cloud environments, and developer pipelines. From that vantage point, they monitor operational controls continuously. The execution layer generates a constant stream of automated evidence, which flows strictly downward into the immutable record layer below. Decoupling these functions creates an engineering advantage. Teams swap or upgrade a fast-moving execution tool without destroying the historical audit evidence safely preserved below. By physically separating governance from execution, an enterprise maintains deep, auditable risk oversight without bottlenecking the speed of daily operations. To see how continuous compliance works in practice, let's focus entirely on that top execution layer. Modern operations generate data volumes manual audits simply cannot track. Here, we see hundreds of daily operational actions flowing through automated compliance gates. This diagram details a specific engineering use case, a CI/CD workflow. The moving packet represents a new code commit traveling toward deployment. Before deploying, the system verifies controls. The gate flashes green, dropping an evidence receipt downward. This automated gating prevents missing controls or late-stage compliance gaps entirely before the software goes live. We see the same principle in healthcare. Hospitals are now hard-coding patient data policies directly into their electronic medical record, or EMR, workflows. Every individual action, from a nurse entering patient data to a doctor generating a report, is monitored against strict regulatory policies in real time. In both scenarios, the system captures audit evidence seamlessly. There is zero manual human intervention required to log the compliance event. The operational impact is significant. Organizations reclaim weeks of engineering time previously lost to retroactive evidence gathering and manual spreadsheet updates. That efficiency directly accelerates revenue. When a cloud provider turns around a SOC 2 report instantly, they build customer trust faster and accelerate new commercial contracts. By natively embedding controls directly into daily workflows, compliance transforms from a reactive cost center into a continuous, measurable business enabler. But this continuous execution creates a new bottleneck, an overwhelming volume of automated log data. This illustrates an intermediate AI layer. It instantly processes chaotic operational data, routing millions of logs into appropriate risk buckets. It also performs accelerated mapping, linking a technical configuration to multiple regulatory frameworks simultaneously. However, this technology comes with a critical limitation. Regulatory agencies demand decision-making processes that are highly auditable and fully explainable. Due to severe liabilities, AI cannot be the final arbiter. It remains strictly an intelligence tool. A human validation node is necessary. The AI suggests a pathway, but it remains locked until human oversight evaluates and authorizes it. Evaluating nuanced policy exceptions, understanding the context behind a flagged anomaly, and predicting systemic cross-departmental impacts are tasks that strictly require human judgment. AI can map controls and surface anomalies at machine speed, but human practitioners remain the irreplaceable core of definitive risk strategy and legal accountability. This cinematic blueprint reflects the core reality of the market shift. Technology tools support a governance program, but they do not define it. One of the most common organizational failures is purchasing a monolithic software platform first, and then trying to force existing business workflows to adapt to the rigid constraints of that specific tool. This backward approach leads to misaligned risk assessments and compliance efforts designed to satisfy the software's parameters, rather than the expectations of actual stakeholders or regulators. The correct sequence is a program-first mandate. Leadership must define their risk appetite and core business goals long before they evaluate any software solutions. Once those goals are set, implementing a layered architecture is the only proven method to balance the necessary stability of enterprise record-keeping with the required speed of operational engineering. Organizations that deploy layered technology to automate the mundane gain a distinct edge. By delegating execution to the machines, they free their skilled human practitioners to drive proactive, continuous business value.